So we can look at to see how these power series give us better and better approximations of the functions. So in the purple here, I've drawn in the e to the x function. So there's our e to the x function. And our power series is going to be a 1 over n factorial power series that will mimic this curve. Okay, so here's my expansion here. Okay, and it just shows each power, the power series is just be x to the power 0, x to the power 1, etc. And the coefficient is going to be generated by this term here. So if I take a look at the partial sum here, and I just have two terms, I have this straight linear function that's touching at 0, so there's my center, so it's just touching at the center. So it only really is doing a good job right at the center. However, if I include one more term, make it a quadratic, okay, you can see that it's approaching that curve a little bit better. And as I increase the number of terms to cubic, 4th degree, 5th degree, notice how nicely it's fitting the curve at this part here. It diverges a bit here, but notice it is getting closer. And as I increase the partial sum, okay, notice that it is becoming a better and better, even at this tail end. As I increase the number of terms, okay, so I've got tons of terms of this polynomial expansion, okay, and I can go infinitely if I want to as well. That's the nice thing about this. I have an infinite number of terms I could use. Okay, so here I've already used, there's quite a few terms in there, and I have my graph starting to match very closely. In fact, you can't even tell. Once we get even to 19, 20 terms, it's hard to tell the difference. And I could even go more. Okay, so as I add terms, it just becomes better and better and better approximation when I do that. Okay, so we can take a look at also sine x. Okay, so sine x. Okay, and we can take a look at that as well. The sine x, the coefficient is going to be 2 bracket 2n plus 1 factorial. Okay, so if I generate that, this is not a sine x, this is sine x. Okay, so there's my sine x function. Okay, we can't, I think I got the wrong